For this question, we are going to do a little bit about Suvat for when the initial velocity equals 0. So we'll start with this question, and we can see that it accelerates uniformly from west, and the distance travelled is 60 meters, and it does that in 6 seconds. And what is required to find is acceleration. So first off, we write out our Suvat as S displacement equals 60 meters. U initial velocity equals 0 because it's from west. Final velocity V is unknown, and the acceleration is what we're trying to find. That's constant acceleration. And time is 6 seconds. So the first thing I'm going to do is write out the graphs for acceleration over time, velocity over time, and displacement over time. Like so. So the acceleration is constant. So we get straight line to the 6 seconds. And the velocity, because the acceleration is constant and it starts off at 0, the velocity will be a straight diagonal line to 6 seconds. And we don't actually need the displacement graph, but I'm going to draw it anyway because it's interesting. Now the gradient of it will start off low, starts off at 0, starts off low, and increases over time. Now we need some equations. So our first basic equation is that the final velocity, v, equals the initial velocity plus any velocity that it would have gained over those 6 seconds. Now it gains velocity because of the acceleration, so this is simply AT. We can also see that it's AT because the units for acceleration are meters per second to the minus 2, and time is obviously seconds, and velocity is meters per second. So meters per second squared times seconds is obviously that. That's our first equation. Our second equation we can get from this velocity over time graph. Now the displacement will be the area underneath this graph over the 6 seconds. And as it starts off at 0, it's simply a triangle. This triangle will be VT divided by 2, as in area of a rectangle divided by 2. So displacement equals VT divided by 2. Now I should add that if there was an initial velocity u, this equation will be slightly different. Now that we have these two equations, we can relate all 3 things that we need. We have displacement, time, initial velocity. Initial velocity is 0, so I can simplify this down to AT. And we want to find A, so I rearrange this for A as in A equals V over T, and rearrange the other one for V equals 2S over T. Sub in this V for that V, we get A equals V, no, A equals 2s over t squared. And we have all of these values, so we can just sub them in as 60, 2 times 60 over 6 squared. And that is 120 over 36, which is your acceleration. I should add meters per second squared.